Welcome to this video where we clearly explain the basics of Qiskit, including setup, installation, and creating your first quantum circuit. Qiskit is an open-source quantum computing SDK developed by IBM, making quantum programming accessible using Python. It allows you to build and visualize quantum circuits, simulate algorithms, and run them on real IBM Quantum hardware. Qiskit is widely used in quantum computing research, algorithm prototyping, and education. It supports algorithms across cryptography, optimization, machine learning, and chemistry simulations. To install and run Qiskit, you need Windows, Linux, or Mac OS, along with Python version 3.8 to 3.12, preferably 3.10 or higher. You'll also need pip, the Python package manager, and internet access for using IBM hardware. Qiskit is modular. Qiskit Terra builds circuits, Qiskit Air provides high-performance simulators, and Qiskit IBM Runtime executes jobs on real IBM Quantum hardware. To install Qiskit using pip, ensure Python is ready, open your terminal, and run pip install Qiskit. You can verify the installation by checking the version number in Python. It is highly recommended to set up a virtual environment to avoid package conflicts. The screen shows commands for both Windows and Linux/Mac OS to create and activate your environment before installing Qiskit. To build your first quantum circuit in Qiskit, you need to import quantum circuit, define the qubits and classical bits, apply quantum gates, and add measurement operations. Finally, run it on a simulator or hardware. This minimal code example creates a single qubit circuit. It applies a Hadamard gate, or H gate, to qubit 0, placing it into a superposition state before measuring it. To run the circuit on a simulator, you import AER and execute. We use the COSM_simulator backend and set the number of shots to 1024 to get the measurement counts. The expected output from the Hadamard gate is an approximate 50-50 probability distribution, meaning the counts for state 0 and state 1 will be roughly equal, around 512 each. To use real IBM Quantum hardware, create an account, generate an API token, and install the Qiskit IBM Runtime module. You then initialize your token in your code and can use devices like IBM_Oslo. Use the Qiskit Runtime service to save your API token and connect. You can then use the service to find the least_busy available quantum computer to run your circuit on. Results from simulators or hardware include measurement counts and probability distributions. You can use the plot_histogram tool from Qiskit.visualization to easily interpret your results graphically.